Hello everyone, this is Upain and welcome back to our YouTube video. Friends, in today's video, we're gonna learn about the lifetimes. And lifetimes are the most and the last topic of our Rust concept. As you can see that after then we're gonna learn about the testers and the projects we're gonna make. So this is the last topic we're gonna learn in the Rust concept, and this is most advanced topic. And so many students seem so confused about what is lifetimes because this is a new topic. You don't see this type of concept in another language. You cannot compare it with another language. That's why this is most confused. But in today's video, friends, I gonna make sure you gonna learn this concept, and I gonna make it very easy for you. So what actually lifetimes do? So in one word, or we can say in one line, they have explained lifetime ensure that references are valid as long as we need. So from this line, you can understand lifetimes are always related to the reference types, or we can say references. So lifetime are the concept implemented or help our reference data type or references. Okay, so let's just close it. Okay, so friends, as you can see, one of the most important detail about the references we didn't discuss in the chapter of reference and borrowing. In this chapter, we have learned about the references, but we didn't discuss a very important concept, which is called the lifetime of the reference. So Rust has lifetime, to support and to manage the reference data type, and we'll talk about that in this chapter. So what actually lifetime is? So this book said every reference in the Rust has lifetime, and which is the scope for which the reference is valid. So basically, lifetime is the scope of a reference for that it is valid. Most of the time, the lifetimes are implicit and inferred, just like most of the time types are inferred. We only must annotate types when multiple types are possible. So what they are trying to say, friends, like in Rust, it can infer the types. Most of the types can be inferred. Like if you write in the Rust, like let x is equal to 5, it gonna infer that this x is I32 type. It's gonna infer by itself. You don't need to write all the type on hard coded on the code. Similarly, in the Rust, lifetimes are also implicit and can easily be inferred by the compiler. Compiler gonna infer it and gonna write on behalf of you. So every reference type has a lifetime, but we don't need to mention for every types. It can be inferred by the compiler. But like most of the type for the like for structs and all, for the bigger type or we can say more complex types, we have to mention the type. Like compiler cannot infer it. Similarly, in the references, when there is a complex references, like a reference can have like compiler is confused, like what exactly gonna be the scope of that reference data type, then we need to mention it. And I gonna show you the with the example. I gonna show you example. I gonna explain it, how and in which situation you can face this problem with. And I gonna show you a error which explain about the lifetime. So just open the VS Code, and I have taken a very simple example here, friends. As we all know, we have created a reference data type like that. Like we have created a variable. Let's start from here. This is a main function. We have created a variable named R, and then we have created a code block. Okay, so we know that this is a scope and this is a bigger scope, another scope. Okay, so we have created another scope, and in that scope I have created a variable naming x, and now we have given the value of x as a reference. So now we are we have assigned the value of reference type of x to our variable r, and now after of this scope we are using r, and we are printing here. So now just try to run this code, cargo run, and we got an error. Okay, so before knowing what is exactly error is, let's just try to understand. We have created a variable r in data scope. Okay, so this is the scope of this variable, and we are using print on this r. We are printing this variable r in that scope only. So there is no problem related to ownership of the r. So what exactly error we are facing? Let's just analyze the error. What they are saying, the error is f does not live long enough. So this type of error regarding to the life, at you can understand it is saying x does not live long enough. So this is a error regarding to the lifetime, and this type of error according to the life of some variable you gonna see in the reference data type only. Okay, friends. So as it is saying, finding x declare here. Okay. So and then we borrowed value does not live long enough, and as we can see, basically we have borrowed the value of x. This is the value, this is our variable x, and we have taken a reference type known r. So we are taking the reference of this value. So what actually we are doing, we are borrowing the value of x. So we have borrowed value x here, but as we know, after the end of this scope, the ownership of this x gonna drop, or the value of the x is gonna drop. So now the value of x is dropped after this scope. They are telling us x dropped here while still borrowed. So what they are trying to say, like x, the value of x is dropped, actually dropped here, but actually we are still borrowing. We have borrowed in the r here, and the scope of r is bigger than the scope of x. So in the r, we are still borrowing the value of x. So what actually happening? Our reference data type r. Okay, let me just close it. Our reference data type r is still borrowing the value of x. We are calling it the reference of x, but the value of x is dropped as this scope closed. Okay, after this scope, the value of x is dropped. So what actually happening here, the value r is using here uh, is dropped now. So r is our dangling reference. You have studied, you have listened about the dangling reference error. This is actually what is dangling is references called. Now our reference data type r is referencing a value which actually not exists. So what we call it, dangling reference. So as you can say, the borrowed values is later used here, but the actually the value is dropped. Okay, so we cannot use here. So that's why we are facing here the error, friends. So from this very simple example, I try to explain you what the life of the references is. And this type of error you gonna only see in the lifetime error is actually only attached with the reference only. Now how can we solve it? So what the error is, what actually error is, our reference data type, the life of the scope of our reference data type is this bigger than the lifetime of data type which we are borrowing. So we are borrowing x, and the lifetime of x is smaller than the lifetime of actually borrowed or reference data type. But to solve this error, we need to make sure the lifetime of the borrowed value and the reference type should be equal or greater. The actually the lifetime of x should be greater or equal to the reference data type of there. So we need to remove this to solve the error. Now we have removed it. Okay, simply we gonna you know make a variable, and then so now you can see that this is a very simple example with just removing the scope, extra scope. Now the scope of variable x and reference data type r is same. So if we try to run this, will not face any error. It is printing the value of r very easily. So that this is what I want to try to tell you, friends, that all the reference type. This is a very simple reference type. And that reference type has their lifetime declared, but it can be inferred by the compiler. So we don't need to, mention the lifetime implicitly. So it is implicitly mentioned. We do not to, explain it or mention it explicitly. Now we're gonna take another example where our compiler cannot infer the lifetime. For that, we need to mention the lifetime. So let me just take you another example. Friends, I have taken another example in which I have created a simple function. We call it the longest. What longest function gonna do? It takes input of two string type. The string slice type we have discussed, as we know, we have discussed about the difference between the string and string slices. So this is a string slice. We have taken the input two string slices, and then we're gonna return the biggest one. We're gonna compare between them, compare the length of both the string types, the string slice type, and then we're gonna return the longest one. Okay, so this is the simplest thing our longest function gonna do. And in the main function, we're gonna we have created a two data type known as string 1 and string 2. One is a string type, second is a string 2 is a normal string slice type. Okay, we call it string literal also. Then what we're gonna do, we wanna uh, call the longest function, and while giving the string one as a parameter, we have converted it into the string slice. But let me remove it and simply make the string one also this type. Will confuse us. Okay, now so we have created a two type. Now I have make it more simpler, and we gonna save the return value. It's gonna return either string 1 or string 2, the longest one, and then we're gonna print the longest one here as a result. Okay, let me run it. So friends, as we can see that we got a error and it is telling us missing lifetime specifier. So what it actually trying to say, we have to specify the lifetime here. It cannot infer it explicitly. We have to tell them explicitly, tell them what is the lifetime here is. We need to specify the lifetime here. Okay, friends. So what actually happening? We are taking the input of string literal string data. Okay, we are taking the input. What is the input? It is a reference type. X is a reference type, Y is a reference type, our return value is also a reference type. And as I have mentioned earlier, every reference type has a lifetime. We have to specify the lifetime for them. For some cases, our compiler can infer it, but in some cases when it is confused what is the lifetime gonna be, we have explicitly tell them we have to specify the lifetime of that reference data type. So guys, if you are a beginner, I have let me explain you with let me explain you with a very simple explanation. What actually happening here when we are calling the longest function, what is gonna happen, this complete scope of this function, let's just cut it here and paste it here. What it actually gonna look, it gonna call the longest function, and let me just, it actually gonna look like that when we are calling it. Okay, and we need to remove this line, but what we gonna do, we are giving a string 1 string 2 as an input here. So it actually gonna create another scope like this here. To explain you, when we are calling the longest function in the result, we are creating a scope like this. We are calling the longest function in this scope, and this is gonna create a smaller scope like this here. And when we are giving the value of string 1 to the x and string 2 to the y, what actually it gonna create here, so let me explain you. It will create a variable x here like that. This is not exactly it looks like, and it will give error. We gonna run it, but I am just creating a mind map for you friends. What actually it gonna look like when we call a function from outside in our scope. So it gonna actually create a smaller scope in our bigger scope. Okay, friends, and our reference data type, this is going to be the reference data type. So let's just refer it here. We are taking the reference. So this is actually x and y. It's taking what they are doing, they are taking the reference of string 1 and string 2. Okay, so now our x has this scope. So what we have discussed earlier friends, like our reference data type, which is x, we call it let x and let y. So our variable x have a scope which is smaller than the scope they are referring to, and our variable y has the scope which is smaller. This is the smaller. Our reference type has a smaller scope than our uh, they are referring to. So we don't need to have any problem for that. As I have discussed in the previous example, the reference data type should have the smaller scope or equal scope with the data type or the variable they are referring to. So in that condition, our reference data type have the smaller scope. So we don't need to face any error here. So why we are facing error? Let's discuss that. So friends, when we when we try to open our error and try to understand the error, what it actually saying, missing lifetime specifier, but this is not telling about the x and y type. It is not telling about the x and y, our x and y reference type. They are telling about the expected named lifetime parameter for the return type. So our code or our compiler can easily infer the lifetime, and it knows it is right for the x and y type, but it is our compiler cannot understand what will be the lifetime of our reference type of our result for the result, and that's why it is confused. We can see that the function's return type contain a borrowed value. So it is telling us, our compiler is telling us our functions reference type contain a borrowed value, but the signature does not say whether it is borrowed from x or y. So our compiler is confused either our reference, our return type. So what actually it is doing, we have created another variable which gonna store the return type of this longest function. Okay, so this return type is not mentioning. Our compiler is confused what exactly this return type is infer with, or what exactly our return type is referring to, and that's why it is confused. And in the error it is telling us like the return type contain a borrowed value, so our return type containing a borrowed value. Okay, but the signature does not say whether it is a borrowed from x or y. As our condition, we can understand if the length of x is greater, it gonna borrowed from x. Our return type, we can understand from, we can try to infer from our logic, if the length of x gonna be greater, our return type is going to be borrowed from x, and if the length of y gonna be greater, our return type gonna be borrowed from y. So in that condition, our compiler is confused what will be the lifetime of this reference. Okay, so return type is a reference, and what will be the lifetime? Is it gonna be the lifetime of x, and is it gonna be the lifetime of y? Okay, that's why our code is not compiling. So let's just, so our code is confused with this reference type result, the let result reference type we are creating. The lifetime of this result reference is confused because it's not attached with a particular, or it is not referring a particular variable. It is either referring string one, or it's gonna be referring string. That's why our compiler is confused, and in that case we have to explicitly mention the lifetime of this variable or reference type. So how we gonna do that, we'll discuss about it. We're gonna explain or use the lifetime variable, which is a kind of generic type. Let's just see how we can mention the lifetime in the Rust programming language. So there is a annotation how we can annotate our lifetime. If we have, let's say, if we have created a reference type like this I32 type. Okay, let's create a variable x which is a reference type, and we call it a I32 type. So our simple reference type looks like that. A reference type with an explicit lifetime. As we say that in some condition we have to explicitly mention our lifetime. So if our reference type has explicitly lifetime, we need to mention it like that. And if the reference is mutable, we're gonna put mute here. And in our example, how can we specify in our example? So let's just move to the code. We need to attach lifetime with all the reference type. What we need to do, add the reference type, we need to mention a lifetime. So this a is gonna actually, like in the generic data type we put t as a generic type. Similarly in the lifetime we're gonna put a to symbolize the lifetime of the variable. And we're gonna also create similarly for that and similarly for that. Okay, so we have created a, we have explicitly added a lifetime with all the variables. This is a x, which is a reference type, y gonna be reference type, and this return gonna be reference type. And we have mentioned the lifetime of x, y, and z gonna be same, or not z, the reference gonna be same, because we have added a generic lifetime a with all of them. So the lifetime of x and y is going to be lifetime of return. So not what actually it is saying, the lifetime of return going to be the smallest between x and y, because the lifetime of x and y we have mentioned is a here. So the smallest lifetime either is x or y is going to the lifetime of our reference. Okay, and we need to, like generics, we need to using the angle bracket mention the lifetime here and say that like that. So guys, this is the syntax we use for the lifetime. So we have connected a lifetime with, so we were facing the error with the result type only, right? So the our result type didn't have a lifetime. So we have given our result type a lifetime, which is a, and it should be attached with a, a variable to which it is referring to. So now our result type is referring a lifetime of variable of either x and y, because both of them has a lifetime. We have put given a generic name a to our lifetime here. So the lifetime of x and y going to be the lifetime of a result, and the smallest between them, because maybe the x has the smallest lifetime or y. So the smallest lifetime is going to be the lifetime of our return. And now just try to run this code, and now we that our code is running fine. It is telling that the longest string is abcd, and if we xyz abcd, we just change our string to, now you can say that the longest string is xyz abcd. Okay, so you can understand, friends, lifetime is very important, and the importance of lifetime, because our reference type should not be dangling. So to solve the problem of dangling references, our lifetime help, or any problem with the ownership of references, like our reference is not referring a variable which is not actually present here. So to solve this problem, the concept of lifetime came, and in so many topics types, we have also seen the using of lifetime variables, or we can say the lifetimes. Just like struct, if we have created the struct and we are taking the reference of struct as a variable, uh, or a return, or a input, we have to mention the lifetime for the struct. Let me show you. So friends, in this example, as we can see, we have created a struct name important excerpts, and we have to, like, as we know, sir, it has a field known as part, and in this field, it is a string type, and we are creating an instance of it here. Okay, we are creating the instance here. This is called let I equal to important excerpts, and so what actually we are doing here, friends, like one of the field of our struct is a reference type. As we can say, part has a string, which is a reference, string slice. So if our struct has a field, one or two field, which is a reference type, we have to mention the lifetime of this field. So what we say, we put a generic on the name of the struct, which says that the lifetime of this struct variable, when we create the instance like I, the lifetime of this I gonna be the lifetime of this part. Okay, this part is going is referring something. So what is it referring? This is referring first sentence. Okay, so there is a variable which is named first sentence, and it is referring to it. So now what we our code gonna see that this, if this is referring that, so it should have a lifetime, or our struct should have the lifetime, which is referring should be the smaller than the lifetime, smaller than or equal to this first sentence. So in that case, we need to put or mention the lifetime in the struct when we use reference type as a field in the struct. I hope, friends, you understand the lifetime completely. I was trying to clear your concept. I think you have a mind map now. If you have any confusion, please comment below and ask me about it. And if you like this video, please like, click the like button of my video, and please subscribe my channel. We'll meet in the next video. Till then, take care.